Hey guys, welcome back to AlgoYogi. We are doing tree series right now. Our next problem in the list is even odd tree. Let's go to the problem on LeetCode. The description is a little complicated, but let's read it out. So, a binary tree is named even odd if it meets the following conditions. And what are the conditions? Let me switch the view here so that we can understand what are the conditions here. First condition is the root of the binary tree is at level 0. What do you expect? It has to be at 0. It's the root of the tree. But anyway, and its children are at level index 1 and their children are at index 2 whatsoever. I don't think that's like really a condition, but it's really saying the root has to be at level 0, which I think it is in most of the cases, but I think the main condition starts with this. So for even indexed level, which is 0, 2, and maybe 4, so these are even. For even indexed levels, all the node at level have odd integer values in strictly increasing order. So all the even levels you are seeing here, the values have to be odd and they have to be also in increasing order. So if you see, the values are increasing in this order, increasing, well, it's just 1, so I mean it's increasing, decreasing, you can't really say, so it doesn't really matter. But for other levels which are at even index, the values have to be all odds. All values must be odd, just like they are here, 3, 7, 9, and they are in increasing order from left to right. All right, from left to right. And for odd index levels, which is this odd indexed, right, odd indexed, and this was even indexed. Okay, so if this is the case, then I want to see the values have to be all even values. At odd index, values must be even vals, and in decreasing order. So it's strictly decreasing order, and you guys can't see it, so let me just move it up. So condition here says odd indexed level, all nodes at the level have even integer, which it has, this does, and this does, this level also does, all the integers are even at odd index, and they must be in decreasing, and that's to strictly decreasing order. So we are definitely using BFS here to solve this problem, and the way it's just, this is a very simple, I see that how the description is like quite really complicated. They have like tried to make it complicated. However, I just simply see a BFS solution where at every level is just, we just have to check which what's our level, and if it is basically even, then if it is even level, then we will have to check if the values are odd. All the values must be odd for even level, and for odd level the values must be even, like just they're just making, you know, cross the even odds here. And then for even level, we just want to check the values must be in increasing order, and on the odd level, which is level 3 here, values must be in decreasing order here, right? So I think it's just maintaining some flags, and once those flags switch, we just need to check if all the values are either even or odd, depending on if it is even or odd indexed. And then we also at the same time we just check if they are strictly increasing or strictly decreasing. If anywhere we come across any of these condition is failing, then we just return false, otherwise we return true. So I think we already know how to write like a BFS solution, so let's code it up and let's get it. All right, let's write our solution. So as I said, we will be using BFS. So first thing first, we need a queue. You don't have to have the condition check edge case for root because they said they will have at least one node, so you can check the range right here, so we don't need to worry about that. But let me zoom in a little. And so we will have root. All right, we got to track care of the we got to track the level, right? Let's have it -1 first, because once we start the while loop we will be incrementing it anyway, so that it keeps increasing for later nodes that need to be processed on the next level. So let's start our not the queue while loop, and if my queue is not empty, then let me take the snapshot of the queue and empty the queue, and then let me increment my level. So let me do these on just one level. Now is when I want to iterate over my one level at a time. So first level would be Q, which is 0th level. So I will do a for loop, visit all the nodes of my current level, so which is enumerate small q, and now depending on the level, let's check if the values are odd on the even level and even on the odd level. So if my level is basically even, that means my values have to be odd. So I will have like a condition if my node.val is even or some condition that I will just write down, we return false. And that condition is if I is greater than 0 and my node dot value. So because this is even level, so on even level, if you see in the conditions, we were checking on the even level, we need to have values in a strictly increasing way, right? So what would be a strictly increasing way? That would be if my current node value is, if my current node value is lesser than or equals to my previous, which is I minus 1. So I minus 1. If that value is basically greater than or equal to my current value, and they were supposed to be in increasing order and strictly increasing order, then I can just return false. And I will do the same check for the odd level, right? But they will be just a little bit different. First is I want to have, first thing is I want to have odd values, sorry, even values. If my value is on my, if my level is odd, then my values need to be even. So I think this is the wrong case, because if my value is not, is my value is even. So if my value is odd, then I return false, because I'm expecting odd values here, and here I was expecting, if it is not odd and if it is even here, then I return false, and this condition will just switch. And finally, we can check if we have left and right children, and we can append that to our queue. So if not.left, then we can append that to our queue. Sorry about the confusion here, because they have stupid conditions. Because if we are at an odd level, so this is an even level, I want to see odd values, and if I don't see odd values, which is if my remainder, if I divide it by 2, is, wait a second, if it is even level, then I am expecting odd values, and if I see the remainder 0, then I will return false. I was correct in the beginning. So append no.left, and same way let's do that for my right child. And that's what I was saying, like it's a simple BFS. It's just these are the conditions that are making this problem a little complicated, but I'm sure you guys can come up with these. And this is just basically simple for checking right and appending right. And then finally we can come out of the while loop and return true if all the conditions passed. So let's go over it again. Initially we're starting with the root, level is 0. If my queue is non-empty, then I'm basically incrementing the level, and then I'm enumerating over queue. If my level is even, then I don't want to see even values. And if I see even values, or I see that my current value is lesser than or equals to my previous value, because I wanted to see an increasing order, and if my current value is less than my previous value, that means it's not an increasing order, then I want to return false. And same way I want to return false when I'm on odd level, and if I see odd values, or I see that my current node value is greater than my current node value is greater than my previous value, because I want to see smaller values as I'm moving forward, and I'm only doing it after 0, because I don't want, if it's just one value, I don't really care. I can only check I-1 index only after starting first index, so that I can check first and 0, or maybe if it is 3, then 3 and 2. All right, then let's zoom out and try to run it. Enumerate, we have some error here, which is for I node, I think we have in. Yes, that's correct. Let's submit, and hopefully this is all good. Time complexity is big of 1, and space complexity not big of 1, it's big of n, and space complexity is also big of n. Alright, so let's go back to AlgoYogi and mark this problem solved, and we are closer to finishing all the trees problem. All right, see you guys in the next problem.